Okay, so thanks everyone for joining and whoever is going to join um, over the next few minutes. This is going to be one of the most insightful and exciting session because of the topic, as it says. So we're going to talk about TDD, and we're going to get into some insights of how it's going, how it's been implemented, and what are the different ways we can also take it forward from there. And we have two most interesting people who have been in TDD for quite some time, and they've successfully implemented TDD in multiple projects and with their teams across the organization. We have Vijay. Vijay has quite a good amount of experience, and he is also into TDD, and he has built a lot of frameworks. He has coached a lot of people, and he also has a decade of experience having done this. And he also likes to sing, so he's an occasional singer as well. So we would like to sometime hear you sing, Vijay. So yeah, it's looking forward to that, and looking forward to your session also. And we have Deepesh. Um, Deepesh has about 11 plus years of experience in testing, and he's come in various stages of testing. He also he's from Pune, and he likes to cook, right? And I, on the other hand, likes to eat. So sometime we should catch up as well. So and so they both have worked together in the organization they are working. They've uh, co-built a lot of framework. They have been evangelizing TDD, and we're glad that we could bring you guys in. And thanks for joining us, Vijay and Deepesh. And having said that, we'll not wait. You don't want to hear from me, but you would want to hear from Deepesh and Vijay. So let's start off with Deepesh. Over to you, Deepesh. I hope you're able to share the screen and you can get started.
Yeah, sure. Thank you for this nice introduction. I'll share my screen and let me know once it is visible. Yeah, should be visible now. Perfect, guys. Yeah, so hello, everyone. Good evening, good morning, or good afternoon, in whichever part of world you are. My name is Deepesh Raut, and as Abhilash has given the introduction, we would start with some basics about unit testing. So I'll just take you through the agenda. So introduction, Abhilash is nicely covered. I'll start up with unit testing overview, and then Vijay would take up TDD overview, and then we will open up for the Q&As. So Q&As would be, you can just type in the YouTube section, and those will come to us. So yeah, let's get started. So basically, let's start with what exactly a unit test or how we define a unit test. So unit test can be a simple chunk of your code. It can be a function, it can be a component, class, function or method, or a property level. So whenever you design your code, you build it using fundamental blocks of functions or classes or any other fundamental units. But in order to ensure that those function blocks or those units are working properly, we need to test those. So this wouldn't have been much trouble if the softwares which we develop now would have been easier, not much complex. But since now we are facing the complexity, so you can see various softwares, and they are so much complex in terms of architecture, in terms of implementation. So these unit tests have become like a part which you cannot ignore. So unit tests are basically those tests which test your functionality at the like bare minimum level. So need not be the entire logic, need not be all the functions, but at least the functions that you develop with the logic which comply to your particular front end, back end, anywhere. So these unit tests does the task of like checking those whether they are properly understood and implemented. So why to use unit test basically? So they gave us they gives us a confidence to understand the basic functionality. So for example, we want to implement a add function, an add function, and you want to check whether that add function exactly does what it is supposed to do. So unit tests help us to gauge us in that particular scenario, wherein whether the function that you have implemented is working correctly or not. It allows the programmers to refine code and ensure that module works properly. So it allows us to refine code basically in the sense that it gives you more idea, more confidence in your code, and sometimes it makes us like confident to develop further code also. Unit testing enables testing parts of project without waiting for this to be completed. So for example, if you start writing the code and if your unit tests are ready, you don't need the functional test or the integration test to be ready by then, and you can start testing from the base itself. So your testing starts quite early if you're going for the unit testing approach. And of course, we have got faster execution times because unit tests, they run at the most basic level. So the execution times are quite faster. Now I'll show you one code snippet. This is a Flask example, which is part of which is written in Python. So what I have done is a simple like a hello function, which just calculates multiple or multiplication of two numbers, and it returns it part of a template. So what I did is I tested it using two ways. One is like when the calculation is done and it is embedded in the index.html or the HTML front end, and another test which tests directly at the output of the function. So like some of you would be surprised, but some of you don't, because they might know that what exactly unit test does. But the test passed in 0.16 seconds over here, and it took over 4 seconds if I use the UI test. So for some functionalities, if we want to test it quicker, we want to test first. So the unit test solution makes it quite easier and a most efficient solution. So for example, if you could say that if PyTest would not have been there, or not PyTest, it is a framework, but if the unit test would not have been there, so the issue, if there is any in this particular execution, would have been found 4 seconds later. And this is just one function. So imagine if you have a complex banking system or a safety system with so many functions, interactions with each other, and like blah, blah, blah. So that 4 seconds would account for tremendous amount of execution time. And that time is wasted while execution happens on the front end. So do we need to do only unit test and just forgo the UI test? Definitely not. But for some cases like this function, in which the base calculation, if it works, we can check using unit test rather than testing it in the front end or the UI framework. Okay. So there are several misconceptions. So I have got only 20 minutes to explain unit test to you, which is not at all sufficient. But I can just explain you what exactly is unit test and the common misconceptions that I've heard through my entire career, as well as while reading some books or going through some blogs or through the Q&A sessions of different YouTube sessions. So the common misconceptions are unit tests are complicated and only developers can understand it. To some extent, we can say like that, but those are like the unit level functions. So if you understand the basic functionality of that particular function or the logic behind that, so then understanding of unit test cases and defining those would not be an issue. So this doesn't apply only to developers, but it applies to anyone who is quite interested in understanding the unit test, for say system analyst or a test analyst. So they can just understand the underlying function, and through that they would be able to design one of the best unit test cases that they can. Then the second misconception is unit test can lead to 0 bugs in end-to-end testing. Absolutely not. So yeah, first of all, no software is bug-free. Second of all, unit test or any system test cannot guarantee 0 bugs. But what they can do is they can ensure that you won't get a base level or the functional level defects in your end-to-end test or the system test. Most of the time, what I feel or what I have heard is unit test, like the unit test, there is no framework, so they cannot do a unit test. Not exactly, because earlier there were some languages, for example, C, in which there were no unit tests, or they were not quite popular. The unit tests were not popular. So people used to avoid unit tests in those areas. But need not necessarily, if you don't have a framework, you should not do a unit test. A unit test is any code or any chunk of code or any function, any class, which tests your function, which is going to implement the logic. So need not be it dependent on a framework. Of course, frameworks make your life very easy to like develop test case, manage test cases, run those test cases, but don't equalize it with unit tests. Unit tests are different, and the frameworks, they help us to execute unit test or to like manage the unit test cases. Unit test guarantees a defect-free product, somewhat lines of end-to-end test misconception, but there is no guarantee was. Unit test, they won't guarantee anything, just they can ensure that if done properly, those bugs which are going to come at a much later level, you can find it like beforehand itself. So what if unit test cases are not done? What if my project or my developers or like the project ownership they don't require unit tests? So what exactly is going to happen? I'll start with this one because this is one of my favorite. So nothing or everything or something might fail. Because unit tests don't guarantee anything, they are going to remove 100% of your bugs, or they are going to find zero of your bugs or anything like that. There is something that might fail, something might not fail. But if unit tests are there, you can definitely know what things are failing, and you can track those. Then probable bugs spill over to the next level, and correct bugs at an incorrect test level. So let me tell you a story, what exactly happened. So I was testing like quite a long time, like 4 to 5 years back. And it was a IoT edge system, and there were a lot of bugs that were coming. Okay, so we started analyzing the system, and there were so many bugs that used to come, and everybody was saying that okay, testing is on the correct path. There are a lot of bugs at the initial stage of testing, and we were part of the system test group, and there were a lot of bugs that were coming. We were raising those, and they were being not carried forward. They were being fixed, and we were everybody was like, okay, now the framework is working, or the process is working. But then eventually, after all those like hard work, like bug of the month, the most bug like count, the person who has raised most bug count award and everything, people started to slowly understand that the bugs which were coming, they were supposed to come at a lower level. So in system test, if you're getting maximum bugs which are not really part of the system test, then that should caution you. So if you are getting bugs at a correct level, the correct bugs are coming, I think you are on a right track. But if those bugs are there and you're finding a lot of bugs which doesn't belong to that test level, so nothing wrong in that. It is good to find bugs, but at the right level, if you find a bug, it is always better from the product point of view. But if you're getting most basic functional defects at a system level, or at alpha or beta testing, then there is something that needs to be done. So unit tests, if they are not done, they may introduce correct bugs at an incorrect test level. So I'll share some common examples with you guys, that what if unit testing not done, what kind of common bugs that you can see. These are not exactly general, they can be different in your project, but kind of you analyze your particular project and see whether this applies to your project also. So really common bugs, like for example, if a invalid password retry is for five tries, and you go until like say 10, 20, and still you're not getting an error. So you become very happy and you raise a bug and everything goes like, okay, now we'll fix it. But take your time and understand whether that functionality or that particular what you can say function or the particular requirement, if it would have been tested at a much lower level, like in case of a unit test, so that would have been avoided in system level. So for example, if you have a like a CI/CD pipeline, and so you go with all your review, then your unit test, and then you deploy it on the QA version, you run your automated test. For some reasons, you might do the manual test. Through all that efforts, you were able to find a bug which was supposedly to be found on the unit level. Conversion defects. So most of you, if you were working in say currency conversion, or like I used to work in gas detection system, so metric conversion of units of gases. So in that case, if basic conversion defects are happening, so yeah, if those are there, you might need to check your unit test. Incorrect error specs. So for example, if you enter an invalid input, and in that case you're not getting an error, or you're getting an error which is supposedly not defining what error it is, it's just giving you an error, or the system is going haywire because of the error was not correct. So when you see such bugs, of course you need to raise it, but as a tester, or if you are part of the analysis group, so you can just analyze why these bugs are coming at this particular level, whether if we can detect it prior the QA or the system level, or is there anything we can do to make sure that the bug doesn't come at a later stages. So unit test, if you can like if the coverage is quite good, if you have covered all the possible cases in your function, these bugs or these kind of functional defects would be minimized in the system level test, and you would clearly able to concentrate on system specific scenarios or end-to-end system, and those bugs would be like mostly aligned with the customers. Yeah. And so what exactly now? So now we spoke about how unit test helps the developers, and how unit test like helps the project to like succeed in the particular mission. So most of the testers, they would say that, okay, we understand what unit test is. We want to ensure that unit tests are done, but is it possible for us to do it? Because most of the cases, the developers or the person who is developing, I will not differentiate between tester developer, that is a different discussion overall. But what if the person who is creating that code, he wants to do unit test because it makes sense, because he understands that functionality better. So what can I do? So you can do one thing. What I do basically is, whenever I'm creating my test framework, so I implement different logics, say for example, to pass a particular JSON, to compare a particular set of arrays, or something like the helper functions. So you can start uh, creating unit tests for those functions. So if you are doing it in Python, so if, for example, I basically like my test case, my test framework is in Python and robot. So in that case, what you can do is you can utilize the base level, the unit test, which is part of the Python itself. And you can just derive few test cases, which can guarantee that your function, which is going to test a particular application or product, is particularly tested. So I would like to stress that unity or the unit test begins at home. Once you start doing it, once you practice it, and then you understand the basics of it, you understand the pains that are involved in creating those unit tests, or like utilizing those unit tests, so you can guide the person who is in need of the believe in the process. Most of the time what happens is, I have given you so many pointers that, okay, if you find these kind of bugs, you would go back and check your unit test cases. But sometimes what happens is you get nothing. So you're getting a lot of bugs, say 50-60 bugs in one test session, and you guys like huddle up and say that, okay, no, we will implement a good robust test case. And you implement that, you spend a considerable amount of time, and then you come to know that, okay, the bugs are still there, or there is no considerable amount of decrease in the bug level. So don't get panicked in the first attempt itself. Believe in the process. These processes or these tests, they have been followed by one of the best developers or the best projects in the world, and those are bound to give you success, not in a long term sometimes, not in a short term sometimes, but definitely in a long term. And yeah, so believe in that process, stick to the plan, and like observe milestone based progress. So for example, if you put your milestone on the count of bugs which you get, I don't think it is a good idea. But like based on the coverage of your test case, if you point out your milestone, it will be really helpful like down the line. Then this is one of the best thing which we can do is sit with the person who is trying to develop a unit test, help him out with certain test scenarios. You can tell them to say corner cases or some boundary values or some equivalent partitioning, which are common test designing practices. You can discuss with the developers. You understand the functionality, help them design the test cases for them. And at the end, you both would be responsible for giving a quality product to the customer. So it is everyone's responsibility. That is what we practice like down the line. But in that case, how you can help to get a robust unit test for your particular project, it can be like these are some of the pointers, and you can just like sky's the limit for that. These are some processes or some pointers which can help you to gain a proper unit test case structure or a framework. But down the line, these are the possible scenarios, or these are the possible pointers that would help you to give a quality product. And my personal favorite, these two, the unit test begins and hope. Please always test your own code, because most of the time what happens is when we develop a test automation code, we rarely write unit tests, or we rarely test our own code. So please do test your own code, do test your own logic, whether it is supposed to do what it is supposed to do. And the third point, discuss the possible scenarios. If you talk to the developers, or you talk to the person who is developing a particular set of code, so when you talk about the particular code or the function, you might be on a different track, and the person who is responsible for developing might be on a different track. You sync with the you both sync, and you try to find out a possible outcome of a perfect unit test case. Yeah, I think that's it from me. That is end of my session, and we have some time for QA. Till then, I think over to you, Vijay.
So hello and welcome to the TDD part of this session. I will continue with where Dipesh left for us, the unit testing. I'm so happy to have this this conversation with all of you, and would be happy to I look forward to all the discussion we may have after this session or any times later. Wanted to give a brief history about TDD. Is it a hype, new hype? Absolutely not. Even 80s, the 18th century, and even the 12,000 BC, I can see references for TDD, but some history I collected from C2 Wiki. The Mercury space program in 1959, they used TDD, form of TDD, which they did on while programming the punched cards. It's 1959. Jerry Weinberg, 1989. He writes test first on the punch cards. Ward Cunningham writes those fit like testing framework. Gary Goldberg also. So test first is also a name of this. Now the coin term TDD came later, but test first is an idea already in prevalent in programming. 1994, Ken Beck writes the test framework as unit for Smalltalk. Was a beautiful language which I know got in C++ got inspired from Smalltalk. Smalltalk is definitely a good language from where many object-oriented languages have inspired, including C++. 1995, Kent Beck demonstrates TDD at Uppsala conference in Austin for Ward Cunningham. Ward Cunningham and Kent Beck both have when they work together for their company, their development style was TDD. Kent Beck in 2002, the book came out, Test Driven Development by Example. The book is significant in terms of TDD history because it made this methodology, this practice, very much. They brought it into words, and it came out from the extreme programming, and it was starting to getting into industry more and more. So this book, Test Driven Development by Example, this is also one of my favorite books where I have learned TDD myself. Fast forward to 2006, it's BDD introduced by Dan North. Started as an extension to TDD, but then it grew beyond TDD up to the business case levels. Again, fast forward to 2008, and that's a nice, interesting fact. Scott Ambler releases a survey showing that less than 1/5 of the agile teams practice TDD. I have a feeling after doing years of TDD that, and through words and talks of Kent Beck and Robert Martin, whom I follow for TDD, they are my TDD mentors. Through my experience and their talks, I see and I feel that for agile to work, TDD is the cornerstone. So that's the brief history. You see that image where everything starts rotates around test, like it's a sun. A test, and then the code rotates around it. I mean, it doesn't rotate. You have a test, then you code, and you again have a test, and that repeats. And after few repetitions, you have some components you can integrate. So then that integration revolution comes in at the third stage, and then the integration revolutions which continue with the test. Then you're ready to deploy at some time. Then there will be many releases you'll do over the period of the roadmap of the product, and then you will steer the industry in terms of what you are providing as a solution, which applies to maybe industries at large and would be significant. So at all, the core of all of this is test, you see. While programming, we used to see code differently, but with the diagram, you see even code is working in tandem with test, and that is what TDD is. We'll know more as we go into the third or fourth slide. For that, I wanted to give some benefits we have from TDD, which I want to highlight for today's session for testers and developers both. I will write tester role and developer role because we do both. I believe we are both many times. We play both roles. even if we are a tester or a developer, we do play both roles. So TDD, how does it help for a tester role? Because I did TDD and it has helped me doing development and testing. I can list down these 3 points. You can develop your components of your test framework, utilities of your test framework, exploratory testing tools, all of that you need to have powerful testing. So that TDD helps you enable as to develop this framework components or testing tools. I have developed testing tools which have really helped me save time, where it could be automated, and or where I could automate some part of it and just focus on what is the exploratory part of it. So it has helped me a lot. Of course, I've done TDD for those tools. Your automated testing becomes more comprehensive, or more scenarios, more complex scenarios, as a result of having that step-by-step process of TDD. It also helps excellently in doing white box testing, because you know how you go from test to code. You have seen a lot of code yourself in your test framework. You know how it breaks down into pieces. So it helps you also, as a result, indirectly, it just helps you in white box testing. For a developer role, we already know the benefits we have. The TDD code helps you take your solution or your code from step by step to higher levels of clean code. Clean code means which is readable. Your solution is more stable, and your solution can absorb future changes very well as you anticipate them, as you put them in your design because of TDD. TDD gives you greater control as a developer over the code and design. You can experiment with design. You can experiment with architecture patterns, optimizing things, trying different optimization techniques as far as latency goes, storage goes, and uh, using third-party solution goes. You can do experimentation a lot. That comes with the greater control over the code and design. Together, for tester and developer role, we eventually helps stabilize the test pyramid. I assume you already know about test pyramid, which Dipesh already mentioned. That there are levels. You start from unit test to modules test to integration test, system test, and UI tests as you go up the pyramid. So if you have at the base of pyramid, if you have lots of unit tests, that helps you to cover the functionality at the unit level, the basic level, and that proves that it works in the important basic units. That makes it easier for the higher level test, integration or system test or UI test, to just focus on those higher levels and at that context only. So that's a stable test pyramid which really helps the whole team. And when you do test driven development, it helps understand both concerns of a tester and a developer, because when you do TDD, you are yourself trying to come up with test first. So you are inherently using your testing ability there, and then you're coming out with your developer skills and implementing the enough code to have go through that, pass that test. So So you're doing testing and development kind of both together in tandem in TDD, and that is why you understand both concerns, uh, how difficult it is to communicate a bug or to reproduce an issue or um, specify the system in terms of test. So the benefits which these are just few of the benefits which we have, which I wanted to discuss for today's session. Now we know few benefits. We can go to know what TDD is firsthand by looking at its technique and some code, quick flash, not much, no hands-on today. Before that, I wanted to add few more points for testers, how they can, they can play for TDD. Testers play a critical role that while developing, when you are developing the solution initially, when the development is going on, testers can play a critical role there in the acceptance test, in the important test, and also cover the corner cases. And this can go on, uh, where testers and developers can help and can add unit test at the base of the pyramid, TDD style. So that helps. Testers knowing TDD helps the team and the development. Testers can improve the unit test written by developers at this base level of test pyramid. Becomes the, as we said, it stabilizes test pyramid. That also helps. So this is we have in my one of my team in IoT, we have done this. We have added unit tests, improved the unit test for the developers, and that has helped a lot because that stabilized the pyramid, and we can now focus more and concentrate more on the system tests. So that said, we should of course come to the point, what is TDD, and know it. We already know, I just repeat, but I'll add some points which could be interesting. So because we are not interacting, we could have asked questions here, but I will just continue. We'll take questions later on. So what is TDD? According to Ray Osherov in the Art of Unit Testing, he mentions a nice way to learn TDD or grasp TDD. He breaks down TDD into 3 skills. Writing a test first. You should be able to write a test first, and then you should be able to write good unit test, and then you should have good design techniques, ability to use or identify good design techniques. So these are 3 skills into one for TDD. That's what Ray says in his book, and also a video related to it I saw. It could be beneficial for some to start with these 3 skills individually, one by one. I mean you'll learn to write unit tests first, then you'll learn to write a very good unit test which focuses on one thing at a time, focuses on functionality, critical functionality at a time, one at a time. And then you will learn good designing techniques. These are the 3 skills you learn one by one, and then you can do TDD. That's one way it could be beneficial to some, I think, but for me and many, I feel TDD should be learned at once, the 3 steps, and when you do that, at least for me, I got it. I got how TDD works. You may say that TDD has a good barrier to learn, but I will say it is it happens because we are learning three things at one time. But this, I'll say this is not so, because these are three different steps, like you see in this red, green, yellow box circles here. So every step is a is a skill, which when you are step one, there's a red circle, then step two green, step three yellow. So red, green, refactor, these are three steps. So every step you uncover this skill, the three skills. So actually when you are doing TDD in these three steps, you are actually learning all the three skills or improving them as you go. So it's possible, and I've for me and many like me have done TDD this way and learned it TDD at once, but it is not actually at once. It is three steps together in tandem. Step one is you first write a test. Even before you write code, you write a test which fails. Now that's a red test failing in your face. And then you just you make it green. You make it green means you write just enough code to make it pass, so that it passes, so that the test passes. And then when you have this passing test, now you can refactor. That is the third step, which is improve code quality. So when you refactor, you make the code cleaner, readable, or absorb new. You can absorb this new code which you got into the existing design, or you can rethink many aspects of the existing code which is there. So all that power comes in the third step of refactoring. So what we have done here is we have separated the problem of optimization, implementation, and specification. We have separated that into three steps. Specification is the first step, implementation is second step, and then optimization is the third step. So that is three step of TDD. You go in very small steps. You write a very small test. Then you write just enough code to make it pass, nothing more. And then you have this small code which looks shabby, maybe copied from a Stack Overflow or somewhere, and it just works, but you want to improve it, make it look good or gel well into the design. Now you can do it after the second step. When the test is passing, now you can go and refactor the test, the code. So if you refactor the code and the test still passes, that means you have improved or refactored without changing the functionality. That is the power of green which it gives. So if you did not have test in the first place, in the first step, if you did not have a test, you will not have a green test. And if you do not have a green test, you will not get the power of refactor. So this power comes when you test first. If you test first, you have a test which is just needed to be meant to be passed. So you make it pass. That is very less code, and then you continue there. From there you go ahead. So that test first creates a magic here. It gives you this ability that the tests will be acting like a judge, always sitting by your side. I mean, when you're changing refactoring, they will always be on your side. They'll say green or red. If they say green, you are good. If they say red, you have to make them green again. So they help you to empower you to refactor if by running those tests again and again. So you should have a test first. looks easy. TDD looks very easy. The problem is how do you, when you practice it, how do you write the test, the next test and the next test? That becomes that requires some practice. So I will note here that TDD needs to be tried and practiced to see the benefits and to get the hang of it. So you should try it, maybe on your side projects, toy projects, or if you get it somehow, you can also try slowly on your work solution parts where there are modules or classes which don't depend much or who have the least dependencies. You can try TDD there and slowly bring TDD in your work. No need to have it upfront everywhere. So that is TDD. Red, green, refactor. Red is first try to test, write a small test which will uncover a small part of the system. Next, whichever you want to uncover, and then you make that test just pass, write that enough code to pass, and then you can now improve the code quality by just looking at the test if it's passing all the other tests, earlier tests which are passing or not, and you can refactor to your satisfaction, and then continue with the next test which will uncover the next part of the system functionality. So notice that you are uncovering system part by part as you go with this test, and as you go, you have a battery of tests getting added, and they're giving you more and more confidence due to the coverage, due to the coverage of the functionality which they are always covering and always signaling you, red or green. That is TDD. Let's see some code. I wanted to give you a feeling of how really it is. It's some code. You see here, just black much Emacs editor, two parts. In the left side, you see some tests. This is the Fizz buzzer program. On the left side, if you read the test names, you will come to know what this Fizz buzzer program does. The implementation is at the left bottom here, def Fizz buzzer. So if you read up on the left upside, top side, if you see the test name, test divisible by 3 gives Fizz, test divisible by 5 gives buzz, test divisible by 3 and 5 gives Fizz buzz, and test not divisible gives number. You see those names. We started, if you are in TDD, you'll just write one test, like the first one, let's say test divisible by 3 gives Fizz. You write that test here, and you will use some assert statement. See, write it like you are using something which is not there, because you're adding the first test here. So there's nothing got Fizz buzzer right now, but you write assert and use that fictional code which is not there, and that of course that test will fail, sorry, and now it fails. Now you implement this Fizz buzzer just enough to make this pass, and then you write another test. Now that's another feature, that the test divisible by 5 gives buzz. Now you write that assert statement, and it will fail because you don't have that functionality of divisibility by 5. So that test fails. This one is still passing. The second test fails. So implement, now go and implement. The second step is go implement enough code to make the test pass. So you'll implement this functionality of divisibility by 5 gives buzz, and then that second test will pass. Now you think of the third part, divisibility by 3 and 5 gives Fizz buzz. Write an assert statement which will of course fail. implement the code, and the test passes. Similarly, the last test, which is test not divisible, gives the number. So make an assert statement where it fails, you implement it and it passes. That's how you go step by step, not all tests together. I just made a snapshot. I'm not, this is not a hands-on session, so I'm not going step by step, but I'm still trying to convey the meaning that here, if you see, we are taking smaller features first. We are taking divisibility by 3 first. We are not taking divisibility by 3 and 5 first, because we have some idea of implementation in our mind. We started with that, but we can't code first. We have to write test first. So we will express that code in terms of test. We will say that, okay, that feature divisibility by 3 we will bring first. So we'll write the test first, which says divisible, if divisible by 3 gives this. So that test comes first, then the code which you have in mind, you go and implement it. You just implement enough, don't think of classes and design, just try to pass the test first. The test passes, then you get chance to refactor. So if you got the test to pass, then you can think of now refactor, maybe improve the readability, and then go to the next test case. And then you take the next feature, which is still a smaller feature, but not, don't jump to bigger features, because you may miss coverage, you may miss tests, you may have to write a big amount of code to just make the test pass. So it's challenging, yeah, but it forces you, TDD forces you to bring a modular design. That way, the system has small parts to it, and they work, and they are tested, they pass. So that's how it is. Yeah, I hope that gives you just an idea of TDD. This is not hands-on. We may have some other session, but I wanted to show you some code which, TDD comes by practice. That's what we should be doing, seeing some code. Okay, so one myth I want to bust, which is TDD takes double effort or double the time. I would quote my favorite TDD mentors. One of them is G. Paul Hill. So for this myth that TDD takes double time, we feel like that because we have this lump of coding fallacy. We feel that coding is a continuous activity. We are continuously doing coding, and then now here you are bringing in TDD, you are bringing tests to in between intermittently, and you're just messing up. You're adding to what I'm doing already. So this is this fallacy. We think that this features, when we develop, they're just a continuous coding activity, but it's not so. Because let's see on this image on the leftmost side, you are programming, which is you're typing some code, entering code, and designing code. You are programming. That's just one part of it, but you're also studying the code which is existing, which is interfacing with your code, third-party code, or your earlier code, which will be calling this new code which you're doing. So you're studying code also, apart from programming. And apart from that, what the coding you're doing, that is, you're inspecting the code, you're debugging when you have issues, you're also testing if it works somehow or not, when you run that app and see if it works or not for that specific thing. So that is he calls GAC activity, geek at keyboard activity. GAK means geek at keyboard. So it nice way, I like that word, GAC activity. So you are doing that, all that. You are inspecting your code, testing your code by running that app, running that small utility or part, and then you also debug because you feel that it does not work as it runs in your mind, but it does not run on actually. So you're doing all that, all those things, all those activities, and you're not just coding. So this is not just coding, this is also testing, this is also debugging, this is also reading, all of that. When we think of implementing a feature, we think that we are just coding, but now we see that it is all testing and coding. We just somehow we think that coding does not include testing, but it is implicitly. Now the question whether TDD increases the time or not. If you see before and after on the right side, if you see the before TDD, you will have this GAC activity more. You are running, your coding, your programming is less, but your debugging, your testing, inspection is more, because you you're not having tests right now. You are relying on your own inspection skills, your own testing and debugging skills. So that activity is more. Scanning, reading activity, of course, that is also there, because you have to read the earlier code, earlier tests, and also the existing code. So this is the three boxes like shown in the just above the before word. Before means before TDD. That's how the proportions are for GAC activity, for studying code and programming. But if you now you do TDD style development, then you see this after TDD, you will see that the programming activity doubles. You are entering more code because you're writing test code and implementation code. You're designing more, so it doubles. Studying code, scanning and reading reduces because you don't need to focus on multiple things. These are very small chunks, because TDD brings that effect that you don't need to have focusing on many things when you're writing your code. So it reduces. The studying code part reduces, the green box reduces, and the GAC activity, which is debugging, which is testing, by running apps and things, these are slashed, not even half that. These are slashed because you now have tests which test small parts. These are modular parts. They run you whenever you write new code. You have all the code which earlier is passing in chunks, in modules, in small parts. So you have less debugging, you have less testing in terms of starting an app, setting the context, and coming to the scenario you want and seeing it happens or not. So testing and debugging is absolutely reduced because testing is happening in micro steps in your TDD tests. So and also inspection now reduces, because if the test is green, you're good to go to the next. So this is slashed. GAC activity is slashed. So you see these three boxes before and three boxes after after TDD, they are reduced. So TDD doesn't actually increase your time or effort. Actually, if you do it correctly, it actually reduces the time. So it brings changes faster. It makes you notice the failures faster. It breaks the code earlier. It breaks the design earlier. So you're not going some rabbit hole of a bad design or an untestable code. TDD forces you to think in chunks. So that's a modular design which comes as a result. Because you are working in chunks, you don't need to remember all chunks because some chunks are already passing. The things you have to focus on reduces as a result. So that becomes a simple design. And remember, simple design is not easy to achieve. On the other hand, if you just go on adding lump of code, the complex design is easy to bring. You usually gather code which is complex, becomes complex soon. But because you're doing TDD, it makes it looks more annoying. This complex design looks more annoying to you when you do TDD. So it forces you to think of simple, small steps. This is a good one. TDD charges you less for one-liner issues. You know, you're debugging a thing and you're debugging for an hour or a day or 4 hours, and you find a small dumb ass error, you fix it, and everything start working again. This one-liner issue, you are spending enough equal amount of time, uh, like it seems like you're debugging some rocket science multi-threaded issue for hours, but it was just to find out it was a one-liner issue. So TDD charges you less for these one-liner issues. Shows you exactly few tests will fail, and then you can go and isolate yourself to just those tests and just those parts of code, and that will be very quick. You will isolate the thing, and it will be faster in TDD code to fix one-liner issues. So that's how it makes your life faster, and not double effort and double time. I will repeat, TDD needs practice, and it comes with practice. You should do it with some side projects, and then slowly start with few modules in your work which don't have much dependencies. Once you get TDD, you'll become faster and faster in your tools, in your solutions, exploratory testing tools or frameworks, whatever you develop, and it will also help the team overall better if both testers and developers know TDD. That's all from my side. We can take few questions if time is available or not.
Hey, hi.
Hi.
Awesome. Okay, Vijay. I think I should say that there are plenty. So much insights that I've not come across, especially the places where you gave a history of TDD, right? And it's not new for us. It's been there for quite some time, and people have been doing it, and things like that is very insightful. And I think from a perspective of how we need to split the role the TDD fits into testing and TDD fits into development. It's much more clear. I think what would be, or even many people who will be watching this, or probably post we finish live, I think people can go to the YouTube and stuff like that. But I'm sure the next question is, how do you implement this? They want to get hands on, look at the code. And I know that's the most interesting part, to see how you sort of plan it out, the entire structure of TDD throughout the process. How do you fit in this culture overall, right? I think that's something that people will definitely look forward to. But other than that, this has been one of the most insightful session that we have ever come across. I think we've done in the Moolya channel as well. But we want to take it one step ahead and sort of also get hands on a little bit eventually. And I'm sure people will be very excited and interested for that. But apart from that, let's see if we have any questions in place. Awesome. I don't see any questions so far. Cool. no questions yet. I'm guessing there'll be a lot of comments coming in. I think we should take it up next time, and we'll also roll out a form where people can fill in their questions, and people who are watching later, and we'll eventually get on to that as well. But other than that, thanks for walking us through. It's been very insightful, and it's very interesting. I think more we talk about TDD, more people should be comfortable. People get and also to understand where we sort of fit in our existing implementations of the projects that we're working on. Not to be really fearful of it, but I think there's a lot of fear in generally in a lot of things. So we should I mean, from the entire session, I believe it's not something that we should fear of. And most important word that I have to put out. But we hope we'll do this once again with more intensity, more hands-on. Thank you for joining, Vijay and Deepesh. And thanks for everybody who has been part of the live. And we'll post our next schedules in the coming weeks and months. Please follow on LinkedIn, subscribe on YouTube. I think you should get a notification on top of that. So yeah, thanks for being here. I think we should wrap it up. Everyone have a good day, and looking forward to the next one.
Yeah, thank you.
Thank you. Moolya, thank you.